Hi guys, this is Ms. Esmendi, and I'm going to talk to you quickly today about chemical equations. So for every chemical reaction, you can write an equation to describe it. And so here's an example of an equation. Now, one thing that is different about chemical equations is that you remember for a chemical formula, you've got these little numbers that go inside the chemical formula sometimes. Now, these little numbers inside the molecule means how many atoms are in each molecule. So this 2 here means that there are 2 hydrogens in one water molecule. Now, this big number in front of the molecule in a chemical equation tells you how many molecules of that we are talking about. That means in that reaction, you need at least 2 of these molecules. So double check that you understood what I just said. Count how many atoms of each element on each side. Now pause the video for a second if you actually want to try this. Okay? Now here's how I would do this, is to keep track of this. So we've got 1 carbon on this side, 4 hydrogens on this side, and 4 oxygens, because it's 2 times 2. So we've got 2 oxygen molecules, each of which has 2. And I've got you the little picture up here so you can get the gist of it. On this side, you also have 1 carbon, 4 hydrogens, and 4 oxygens, okay? Notice it is the same, okay? Because in a chemical reaction, nothing is being lost or destroyed. It's just kind of scrambling around and reconnecting in different ways. If you think about it, this will make sense. The law of conservation of mass means that mass is not created or destroyed in a chemical reaction. All the atoms are just being pulled apart from the other atoms. You're not destroying any atoms in a chemical reaction, okay? So whatever mass you had before the chemical reaction, you're going to have that mass after the chemical reaction. It's all still there. It's just reconfigured, okay? So the total mass of the reactants is equal to the total mass of the products. Now, about how these chemical formula works. There are special names for the different parts. So the parts before the reaction happens, they're called the reactants. They're the things that react. The things that come after the reaction are called the products, and they're on the right side of the equation. There's always an arrow, and the arrow tells you that's when the chemical reaction happened. So then some stuff happened, and then you had water. So you had hydrogen and oxygen, then some stuff happened, and then you got water. There are also coefficients, and this is going to be important more and more later on, that tell you how many of each substance. So this 2 here means there are 2 hydrogen molecules. This 2 over here says there are 2 water molecules. Now, just like in math, you don't show the coefficient when it's 1 usually. You can, and it's not wrong, it's just not usually done. You can do it, and there are some, like if I ask you how many of this, then you're going to say, how many of this oxygen molecule, you're going to say 1, okay? But usually, just like in math, you don't write 1x, you just write x. Okay, checking that you got what I was saying about that conservation of mass. In the complete reaction of 22.99 grams of sodium with 35.45 grams of chlorine, what mass of sodium chloride is formed? So this is describing a reaction when sodium and chlorine react together to form sodium chloride. And it's saying how much of that do we get? Okay, you add up what you had, okay? So this much sodium plus this much chlorine, and assuming that it all got used up, is you just add those together, okay? And you're going to get the sum of those 2 things of sodium chloride, okay? Learning trick number 2. If you had 10 grams of a sample of magnesium which reacts with oxygen to form this much grams of magnesium oxide. How many grams of oxygen reacted? Okay, now this one's a little bit different because we had magnesium plus oxygen, but we don't know how much oxygen. That's what we're trying to find out. But that equals this much magnesium oxide. Okay, so in our reaction, we've got magnesium plus oxygen equals magnesium oxide. And you just add up the grams, okay? So 10 grams of magnesium plus some unknown amount of oxygen equals 16.6 grams of oxide. And from your lovely days in algebra, I'm sure you know this. And it may look a lot more like a regular kind of equation now. And so you just solve for you'd solve for this. This is basically your x, how much oxygen. So this amount minus 10, it's going to be 6.6. And I forgot to make a slide. It said 6.6. Okay, that's it for this, and I will talk to you later.